Greetings. In this one, I'd like to solve the limit as x goes to 0 of this function. So let's say I have a limit, I'll write it a little bit lower. So limit as x approaches 0 of this function, let's say tangent x over sine of x. Alright, so where x is the argument of these two functions, and you see there is numerator and denominator. Numerator is tangent x, denominator is sine x. And so my goal right here is to take the limit of this entire function, seeing tangent x over sine x as the function, as the argument of the limit. And the limit is parameter, or its property is that the x variable goes very close to 0. Alright, so how do I solve this? Is basically by realizing that if I put x equals 0 straight into this function, then I will obtain sine of 0 in the denominator. And sine of 0 evaluates at 0. That means that I will have a 0 in the denominator. And for that reason, I have to use algebra and trigonometric algebra identities manipulations a little bit in order to rewrite this formula. And once I finish the limit and got the result, I'll just quickly explain the point of it. So, in a little bit more general terms, I won't draw exactly the graph of this particular function because it's a little hard to draw maybe, but I will draw like a general idea and how it can be viewed. So the basic idea right here is that I can rewrite this thing in a way that I no longer will have anything evaluated in the denominator. And how do I do it? Well, in this particular case, sine x, well, I won't rewrite that, but I will rewrite tangent of x. And a very useful thing to know is that tangent of x equals to sine of x over cosine of x. So in general, whatever argument there is, tangent of an argument is sine of that same argument over cosine of that same argument. That means that I can rewrite the tangent of x as sine x over cosine x. So sine x over cosine x as follows. And then the denominator stays the same way. And so I get this thing. And of course, this is still should be written as the limit of this. So the limit x goes to 0. And so of this thing, alright? So it equals the limit of this thing as well. Now this is just tangent of x rewritten in terms of sine x and cosine x. And the useful purpose of this is that the sine x can cancel out now. This new part of rewritten tangent x can cancel out with the initial denominator, which was kind of the issue. And so this sine x can cancel out with this sine x, but not necessarily. I won't write it like this, just for it to be a little more visible. I will rewrite it once again. So it is the same like limit x to 0, and then it is of this function sine of x over cosine of x, and I'm just rewriting this algebraic expression in yet another way, times 1 over sine of x. Alright? So the basic idea here is that I can cancel out these two things as follows. And the only thing I have left is 1 over cosine x. And now that finally I get limit x to 0 of only 1 over cosine x. Of course, this can be written as secant x, but I won't do it because, of course, I know far easier and quicker how to evaluate cosine at 0. And so what I can do now, of course, no longer is this limit needed. Now that I have it written as follows, this limit is no longer required to even consider. I can just say that I'm plugging in x equals 0 into here. Because indeed, cosine of 0 is no longer a 0, but cosine of 0 evaluates as 1. And so this ends up being 1 over 1 equaling 1. That's the idea. So what I did is, I got this initial function and I gradually rewrote it many times until I got an expression which no longer had a 0 in the denominator, which could be evaluated normally. And so the idea is, although this was a function very much equivalent to this final thing, it was not exactly the same. So now that I know the value of the limit, I'll just quickly come to the general idea that's behind this that I want to show at the end. So the general idea can be seen as such, that I have a graph of a function, let's say, and I can view it in the way that, of course, I can write it as, for example, tangent x over sine x. And is it the same exactly like the final 1 over cosine x that I got out of it? I basically just use algebra and trigonometric identities and knowledge of that to rewrite this as just this. But was it really exactly true that this is equal? Well, to answer it, I'm not drawing the graph of tangent x over sine x, of course, but I'm drawing the graph of something, whatever it is, whatever function it is. And as one can see, it's smooth and continuous, especially on the interval near the point that I'm evaluating. So even if it was not somewhere else, but at that small part, it is continuous. So I'm caring about, let's say, for some reason at x equals something, let's say x equals 2, for example, in some case, there suddenly is a discontinuity. And so when I see that everywhere it is smooth, or at least, let's say, even if it was not smooth a little further out, at least in the vicinity here, it is smooth and continuous. And the path is clear. The path tells me that if I go from here, it approaches this point. If I go from the right side, it approaches this point. And just this point itself, when it finally would fly there, suddenly it's not there. It's not there. It's just left out. Why is it left out? It's because instead of 1 over cosine x, the idea was it was rewritten as tangent x over sine x. And in such case, when there was x equals 0, so in this case it was about x equals 0, and x equals 0, although around it was quite nice, at that exact point, that point was just left out suddenly. On that curve, that only one point was left out. And so in order to make the function rewritten in a way that that point is no longer left out, it's just to rewrite it in this form. And thereby I can evaluate the value at that point. Although, of course, in this way of writing it, this function does not have this value. This function does not have a value at x equals 0, while this one does. Alright? So the function can look same at other parts of the range, of the domain, but then at one point suddenly there's that value not. And I have to write the function completely, and again, it will be graphed the same way, but at one point, for which I needed this limit, I can suddenly get it when I rewrite it. But before, it just wasn't there. So that's the kind of analogy for why I switched from here to evaluate the limit. The limit was this only point that was not available for evaluation, but now after writing, it suddenly became possible to get.